Morning class. Today's lesson 5.4 is on irrational numbers. We've talked about a bunch of different numbers already. We're looking at irrational numbers next. So far, talked about our natural numbers. These are the counting numbers, 1, 2, 3, 4, 5, etc. Whole numbers, add to that the 0. So we have 0, 1, 2, 3, 4, 5. Integers, bring it to the negative side of the spectrum. So we have negative 5, 4, 3, 2, 1, 0, all the way up to 1, 2, 3, 5, etc. Rational numbers, any number that can be written as a fraction. Basically, this will include decimals and repeating decimals. But we got to take it one more step to our irrational numbers. These are any numbers that cannot be written as a fraction. So things like pi, square root of 2, or we could say this radical 2, radical 3, or square root of 3, radical 5. You're going to hear the word radical about 1,000 times in this lesson, but let's keep rocking. As you look at these, you're going to want to get in front of you a copy of a perfect squares table. I will be posting one of these onto Classroom as well, so you can have it up on your iPad. It'll just help make things go smoother, and it holds for you numbers 1 through 32 in the perfect squares, because when we take the square root of 1024, we're going to get 32. If we take the square root of 441, we're going to get 21. So you're going to see a couple of these special features. So keeping this table handy is going to be really useful. Product rule for radicals. As we talk about how to manipulate our radicals here, we can look at a couple of different things. So first things first, if we have a radical a times b, we can break that down into radical a times radical b if a is greater than or equal to 0 and b is also greater than or equal to 0. Well, for this lesson, all these things are going to be, for the most part, greater than or equal to 0 for the most part. We can do a couple of modifications if we need to. So let's take a look at an example. We have the radical 20, also known as square root of 20. Well, obviously there is no clean square root of 20. However, we can flip that into radical 4 times radical 5. So actually radical 4 times 5, and then we can break it apart to radical 4 times radical 5. And we know that the radical of 4, or the square root of 4, is 2. So we're going to have 2 times radical 5. And so that means the radical 20 is equal to 2 times radical 5. That is the product rule for radicals. Now, we're going to always have to simplify radicals all the way down to the most simple forms. So let's do another example. 32. Well, as I look at 32, is that one of our perfect squares? Unfortunately, it is not. However, inside of 32, we can find the factors 16 and 2. So if I go radical 16 times 2, I can break that apart to radical 16 times radical 2. And then I can take the radical 16 becomes a 4 times radical 2. So 4 radical 2. Another example. A negative sign. Womp, 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 womp. Just kidding. We can get rid of that by factoring out negative 1. So I've got negative 1 times the radical of 250. And I already took it one more step further to say that's the radical of 25 times 10. And obviously the radical of 25 times the radical of 10, I can break it apart a little more, keeping that negative 1 out in front. We'll just hold on to that a little longer. Radical of 25 is 5. Radical of 10, we don't have a real good number for that. So now we've got regular good old-fashioned integers. So I've got negative 1 times 5 gives me a negative 5 radical 10. Okay, so when we look at radicals, especially in the homework, you're going to be doing some flipping and flopping. Simplify every time. What if we have to add radicals? Let's take a look at that. So if I have 5 radical 3 minus 2 radical 3, you can think of that, plus a radical 3 at the end. You can think of this as being like x's. So think of it like 5x minus 2x plus x. As long as your radical is the same, you can combine the coefficients. And so in this example, 5x minus 2x plus x gives you 4x. Going back up to our radicalization, we've got 4 radical 3. So again, think of the radical kind of like a unknown or like a variable. It's got to be the same, obviously, but if you treat it that way, you'll be able to work the numbers kind of the same way. Another example here, we have 5 radical 2 minus radical 72. Well, we have to do some simplification first. So we can simplify radicals as necessary. And if we take a look at that radical 72, we can say radical 72 is radical 36 times 2. So now we get 6 times radical 2. And if we go back to the original problem, 5 radical 2 minus 6 radical 2, remember, we can treat it like good old-fashioned coefficients. We're going to get negative 1 radical 2, which can be simplified down one more step to negative radical 2. Radical. Let's keep rocking. Multiplying radicals. Oh boy. This is a similar kind of concept here. If we have radical 3 times radical 27, we can do some multiplying here. Just like we did at the beginning where we were separating them out, we can actually smush them back together. So if I go radical 3 times radical 27, that's equal to radical 3 times 27. And radical 3 times 27 is going to be 81. And guess what? That is a perfect square. Radical or square root of 81 is 9er. Here's another example. Radical 6 times radical 10. We then smush them together underneath the radical symbol. Radical 6 times 10. Multiply those out, we get 60. Is that simplified? No, it is not. We have to do some simplification work yet. So that work is going to come in this regard. We look at 60. We can factor 60 out to 4 and 15. We have radical 4 times 15. Radical 4 is 2. And we have that radical 15 left over. So 2 radical 15 is our simplification. So we always have to remember to do our simplification work. Can we divide these things? Absolutely we can. Remember, division is just the opposite of multiplication. So if we can do multiplication, we can do division. We start off with radical 8 divided by radical 2. First step is going to get them all under the same house. They're going to be under the same radical. Radical 8 over 2. Well, what is 8 over 2? 8 over 2 is actually 4, and you can see radical 4 is one of our perfect squares, giving us 2. The next example, we have radical 96 over radical 2. We can smush them together and put them underneath the same radical. We've got radical 96 over 2. What is 96 divided by 2? It is going to come out to 48. Is that done? Negative, Ghost Rider. We still have some simplifying to do because I can see right away 16 will fit into 48. So I get factor 16 times 3. The radical of 16 is 4. And then we have radical 3 left over, so it's 4 radical 3. So in each of these, we're going to be working on that different radicalization. We can also rationalize the denominator. Sometimes you're going to get problems like this. Oh my, what do I do? Well, just like simplifying out problems, you can't really have a radical in the denominator, but you can get rid of it by multiplying by 1. However, our 1 is going to be fancy. We're going to do radical 2 over radical 2. That's amazing. The multiplication here becomes 5 radical 2 on top, and on the bottom, we have radical 2 times radical 2, which is, we can smash them together, become radical 4. Well, guess what? The radical of 4, or square root of 4, is 2. So we wind up with 5 radical 2 over 2. Another example. We have 5 over radical 12. We can multiply both top and bottom by radical 3 because that gets the bottom to radical 36. And radical 36 is a perfect square. So in doing so, I have 5 times radical 3. I have radical 12 times radical 3. We get 5 radical 3 on top, and on the bottom, we get radical 36. And radical 36, aka the square root of 36, is 6. So I have 5 radical 3 over 6. There are 3 problems that I have on the homework that kind of talk about approximating square roots. And on the homework, I say no calculators. However, at the very end, if you watch this video, if you read the instructions, I guess, as well, you can check it with your calculator. But here's kind of how we work these out. If I have the square root of 73, I can't say flat out, yes, that's going to be a perfect square. Also, it does not factor down into perfect squares. So if I look at my perfect square chart and I find numbers that are close to 73, I've got a perfect square that's lower than 73 in 8. 8 squared is 64. And I've got a perfect square that's higher than 73 in 9. 9 squared is 81. So that's 81 is high and 64 is low when we got 73. So it's going to be somewhere in the midst between 8 and 9. And it's kind of literally like middle. So it's going to be pretty close to 8.54. And I can use my calculator to check. And if you have the square root symbol on your calculator, you can definitely jump on there and just do a real quick check. But I did want you to kind of crank it out and practice and look at it and think about it. Another example is negative square root of 17. Again, we pop that negative symbol off the front and we look at square root 17 or radical 17. Well, the two numbers I have closest, we have 4. 4 squared is 16. And we have 5. 5 squared is 25. Now it's closer to the 4 squared end of it because 17 is only one more than 16. So it's going to probably be something like 4 point something small decimals. So this instance here, it's 4.12, and we can't forget the negative symbol out in front there. So again, you're going to approximate first, then you're going to use your calculator to see how close you are. The last example here, plus or minus square root of 198. We're not going to play around too much with that plus or minus symbol out front there, but instead I look at the square root of 198. My two perfect squares that are close, I have 14 squared, which is 196, and I have 25 squared, which is 225. Well, it's a lot closer to the 196 end of the spectrum, so I'm going to speculate it's going to be like 14.0 something, and that's what it is. It's 14.07 plus or minus for this instance. So just try looking at your perfect squares table and figuring out the couple that I had on the assignment. But that's how you can kind of guesstimate a square root. All right. And that's the homework here. So let's take a look at what we're doing. Again, read and review pages 214 through 218. Your homework is going to be found on 219 and 220, and these are the characters for your homework. If you are not sure, I do have it posted also on Classroom, so you can check that out. We got 4, 6, 10, 12, 14, 18. Well, I'm not going to read these. You guys can read these on your own. Like I said, 80, 82, 84 are the three you're going to do without a calculator first, and then you're going to check them. Best of luck. Email me if you have any questions. I'll see you in class.